Okay, so right now we're going to continue and we'll be hearing about workflow management from Petr Votava. Thanks a lot for offering to give this, Peter.
No problem. Good afternoon. So my name is Petr Votava, and met with you earlier this week. And together with Rama and Andrew Halis, been leading the development of NASA Earth Exchange, or NEX, a role that we're now sharing with the NASA Supercomputing Division folks, that some of those you met this week. I'm mainly in charge of the data and the software platform, and also the web portal. So I'll talk today about workflows, but before we get started, I wanted to do, listening to John Townsend yesterday, I want to do a quick reflection on how the NEX project kind of came together. Because what he had to say really kind of struck me with when he talked about luck and opportunity. And secondly, it goes back to what he said about trying to be a better speaker. So I decided for a few minutes at the beginning, to step outside the box and outside my comfort zone, and try to tell you for 5 minutes about what we've done, how we got lucky, and also all the other people that contributed to the project. There's lots of them here at NASA Ames. I'll be brief because I'll probably be scrambling since I'm going to attempt to do a live demo on top of that. The good news is that the demo, and I'll point you to the resources, it's all online. You'll be able to actually download the software locally, and you'll be able to, they have some phenomenal tutorials, and you should be able to go through it. So even if I don't get through everything, if it's something that you're really interested in, I encourage you to go and play with it later on. So about 3 years ago, Rama, Andrew Michaelis, and myself were asked to put together a proposal for recovery money that were awarded to NASA. We had to write a proposal in really quick turnaround time, so something like 2 days. And I remember it was in the afternoon, and we were sitting in Rama's office, and he got the call, and we're there, and we were not panicking because we already had the proposal. Because about a few weeks earlier, kind of unknown to us that this is how it's gonna play out, we decided to write a proposal that would be 1-year extensions on one of our technical projects. At the time, we kind of thought, we're going to write it, even though we thought it was going to be, a somewhat futile effort. But the reason we wrote it was because we decided that there was some new technology that we wanted to try out, and we want to kind of think how we can use this technology to help our group, our science team, to kind of advance what it is that they're doing. So we just did it, and by luck, we didn't submit it. And also by luck, the ARA money showed up, and we were ready to go. I mean, we had to take it, polish a little bit in a couple of days. So, as John said yesterday, sometimes there is an element of luck because you just don't know when the opportunity presents itself, but you kind of need to be ready to recognize it and act upon it. As one of my other teachers said, you have to be present to win, and that really stuck with me. If you move here in the dorm-like settings in a formal naval base in the middle of summer and spend all days here in this heat, and probably eat cafeteria food for breakfast and lunch. I'm not quite sure what you guys do for dinner, but so that's I think that's tremendous, and it shows that you really want to do this, and good for you. So there are a few other people that and groups at NASA Ames that want to recognize for the NEX. The first was Forrest Melton, who was instrumental. He's part of our group, and he was instrumental in getting the NEX proposal polished, and also managed a number of aspects of it, mainly in terms of subcontracts and contracts and some of the financials, while running his own ARA project. So if it wasn't for him, both Ram and I probably would have a lot more gray hair, even though she was pretty good. Second is the entire group at the NASA Advanced Supercomputing Division. You were there yesterday. They were giving you talks this week, and so you get to see a little bit what it is that they're doing. But they just provide us with incredible support and leadership in many aspects of the project. And without them, a lot of these things we would not be able to do at the scale that we were able to. So the connection was made by Senator Lee at NASA headquarters, and I'm sure that when we showed up at NASA, they probably didn't quite know what to think of us. There's three guys talking all crazy plans. What is they gonna do? But they listened, and they've been, just providing us. They've been incredible partners for us for the last 3 years. And you heard many of them, and I have to say that those are some of the best people in the supercomputing field that you will ever meet. So I think it's really special that they come here and talk to us. I'll definitely have to listen to some of those talks myself later on. Next is the Dashlink project at NASA Ames at CodeTI, who developed basically the first or one of the first NASA-like social platform, web-based. And they've been instrumental in getting our portal up and running and developing and maintaining it for us for the last 3 years, and providing us with really, really good support. Estelle Dotson's team, with Mike is part of, with the NASA Astrobiology Institute, providing us advice on technology for collaborations. Once again, without them, we probably wouldn't be able to do it in the way that we're doing it right now. And finally is the team that I've been working with for most of them for the last 10, 15 years, and that would be Christina Milesi, Hirofumi Hashimoto, Weila Wang, Gong Zhang, Alberto Guzman, Sam Hyatt, Sangram Ganguly, and Kazuhito Ichi. There are a few others that kind of come and go in the lab, but they really contributed their effort, to this, and actually made the project relevant from a scientific point of view. So while the underlying technology might seem, cool and fun to me, at the end of the day, it's really the scientific results that matter. That's why kind of we're here. So we're not developing the technology in a vacuum, but actually, use it to provide some results. Okay, so that's that. Now to the demo and the talk about the workflows. So the major contribution for this was done by the Vistrails team, David Coop and Claudio Silva from NYU, and they've been developing Vistrails since about 2006. And I'll talk a little bit about some of the aspects of the system, what kind of caught our attention, and then I'll try to do some demo and see how that goes. And Jennifer, you keep track of my time. Yeah, not too bad. Oh, 15 minutes. Okay, so the outline, talk a little bit about the goals of this. I'll give you a little bit background on workflows, not much. Do overview Vistrails, then we'll do demo, and then kind of try to tell you like where Vistrails are heading, at least from what I know, and then how we use it, or how we integrating it with NASA Earth Exchange. So the goal is to basically provide background on workflows with emphasis on the workflow management system, and to demonstrate some of the Vistrails features. It's not really an in-depth tutorial, but more of an introduction to the software package and some of the capabilities, in terms of provenance and transparency and reproducibility and so on. And if you're interested, they have really, really good documentation. They're gonna be links throughout, and you can go and check it out. And you should be up and running really quickly. That was also one of the things that I really like about this package, that you can actually be up and running in no time at all. Okay, so some terminology, because you might be hearing it. Workflow is basically just a sequence of connected steps. So you can think of a script as like the simplest form of workflow. Originated in manufacturing way back then, so you can think about assembly line. Somebody does this, and then things kind of move through. Things like data moving through the system. The workflow management system is something that manages the execution of a workflow and enables users to define and execute new workflows. This is often done in graphical user interface. So you just drag and drop a bunch of boxes around. You connect them with the links, and I'll show you kind of what it looks like. The workflow engine is something that implements actually the coordination of the steps. So like Java Virtual Machine. Well, it's just something that makes things happen. Okay. There's tons of them. There's dozens and dozens of workflow engines. A lot of their use in business and manufacturing. They start being a little more popular also in science, but it can be sometimes kind of hard to navigate. It's kind of intimidating because there's just so many. but so we kind of play with some of them, and we just made certain decisions on where to go. I was gonna say the workflow management system, workflow engine, sometimes is used kind of interchangeably, and so, but I don't, it's just something to be aware of. So some examples, so Apache has the ODE for execution, mainly for business processes. There's a Taverna workbench that's been used for actually scientific processes. A lot of it is Java-based. They have really good, this is my experiment collaboration site. Another scientific workflow system was a SciFlow out of JPL, which deals with web services orchestration of scientific workflows. And it has some capabilities that can move operations to data, which is very important if you don't want to move large amounts of data around. With that, I would still say that it can be still a bit problematic, because if you have if you're connecting 3 different, variables, let's say if you want to calculate NDVI and your red band is in one center and, your NIR band is another center, then no matter what you do, you have to move some data. And sometimes it's almost, the workflow folks, they do it almost too nicely, because when you write the code, it almost looks like it's all located in your machine, but it's not. And then you make, operation like that, and if the engine is not smart enough, or if it's just too hard of a problem, so anyway, I just kind of throw it in there that it is not something that solves all the problems in the world. But that was also one of the reasons we decided to start NEX, because we said, well, it's just too hard to, some of these problems can be quite complicated. So, well, we'll just bring all the data, and we'll just put it right here, and you guys will know what to do with it, which mainly has been the case. And I think it worked out really well. So we spent a lot of time actually bringing and organizing the data, because that seems to be some of the very largest tasks for for scientists to deal with. Okay, so workflow can be simple. For example, recipe for hard-boiled eggs, or it can be a lot more complicated. So this is a workflow. This is the entire processing workflow for the Modis products, for all of them. And I expect you to be able to reproduce it by the end of next week. No, but so things can be kind of complicated, and each of the boxes right there, it's some really complicated algorithms, and it has another workflow within it. So there is all kinds of things. Okay. So why did we pick Bistros? So we picked Bistros because it provides built-in provenance capabilities. And even though you can edit to some of the other workflow systems, and it might be already by now part of some of them, we just made some decisions. So that was one of them we made, that we're going to go with Bistros. The other thing is Python-based. And majority of our scientists actually use Python to integrate their code. So it was something that we could just pick up really easily. We didn't, I was the last one actually to switch to Python in this group, in like 3 years ago, or so. But so this came really handy because we were able to integrate some of the code, fairly quickly. It has excellent graphics capabilities. Bistros has been developed by a group at the University of Utah. It's been one of the top places in the world for computer graphics. And they actually originally developed it to teach their graphics classes. So it has really, really expensive graphics libraries. I don't know what most of those things are, but they can produce some phenomenal visualizations. And the other thing, it provides really easy integration, with legacy software, which also was kind of a big deal for us because we have, we don't want people to rewrite stuff. We just kind of integrate with some wrappers and throw it in, and you'll see, if you try it out, it really very intuitive, and things we can make things happen pretty quickly, which was important. Kind of in this environment, we're trying to be a little more agile rather than like. Anyway, so to talk about. This is kind of complicated, but basically it says that, throughout the data analysis, we hope to generate knowledge. And the key part of it is, basically refining and extending analysis based on what we know now. This is an iterative process, right? I mean, you change some parameters and you want to see what happens. You change it back, and you want to see what happens then. What's tricky is how do you actually keep track of all the things that you've done up to a certain point? How do you keep track of what you've tried in some meaningful way that you know what you've done? Because, you know, this can be very lengthy effort. So, you know, sometimes you need to kind of take a step back, you know, iterate a few iterations back and like take a different branch, take a little different approach. So, you know, in science, provenance is basically the lineage of data, computation, or visualization. It is often, and it's becoming, you know, to the point that it's, you know, almost as important or more important than the results. Because you need to be able to track it back and people being able to see what you did and why. So the old solution was the lab notebooks. You know, so new problem with that is like large volumes of data, very complex analysis, and just writing notes just, you know, it won't scale up to a certain point. So, you know, a very simple example on provenance that, you know, something that people are familiar with, photo editing, right? So you start with the image, and you say, it's a little bit too light, so you darken it. It's a little bit too blurry, so you sharpen it. Think, well, I don't really like the red in there, so make it grayscale. And then you decided, well, you know, I want something more artsy, so, you know, I'll make it watercolor. Okay, so you know, so this is something that you use. Now, if you're at the watercolor point now, you cannot go back to the grayscale image. You cannot, you know, because the path that you're working with is linear. So undo and redo stacks are linear. So we lose the history of the exploration. So the old solution, people saved the intermediate files or the states. The solution in Vistrails is actually automatically and transparently capture the entire history as a tree. Users can tag or annotate the different versions and can also go back to any version by selecting it in the tree. You know, some of these things get a little bit more complicated, but I'll actually show you hopefully this example and, you know, some of the features that they're provided. So, you know, Vistrail system provides comprehensive provenance infrastructure for computational tasks. The focus is on exploratory tasks in collaborative environment, collaborative design of scientific processes, and interactive parameter space exploration. It tracks the provenance transparently from data acquisition to visualization, and, you know, the user can kind of follow the trail of their experiments. And also helps, you know, the provenance also helps to streamline some of the exploration. It is open source. It's a freely downloadable system at vistrails.org. It's multi-platform. Actually, it's kind of tricky to build on Linux because it has a lot of dependencies. Except, you know, there is supported some platform like Ubuntu is supported out of the box, I think. But, you know, Mac, Windows, you basically download it and you should be up in like 10 minutes. Is, you know, good users guide, wiki, mailing list. It has many users in different disciplines and countries, and, you know, as I said, you can try today, and you can explore all of the examples that I'm going to show you in next. What do I have?
You
half
have
an hour.
35 minutes.
Okay, so in 35 minutes, and then the ones I don't show you, you can go, you know, because they have good tutorials too. So okay, so let's try the live demo here. All right, I gotta get to my live demo slides. Okay, so all right, so start Vistrails. Would you see, and I'll talk about each one of these, the pipeline view, the history view, the storage view, the explore, the provenance. Probably won't get to the mashup. But what you have here are basically workflows. This is, you know, I have it ready because these are things that I used earlier. And the way, you just kind of double click. It's kind of funny, it's a delay from my laptop too, so I think something is wrong if I don't see it on the screen. But, and so this is your basic workflow. So you can move things around, you can kind of arrange it. You can have these basic modules here. So if we develop like an NEX module, we have it out here. They have some basic modules they're provided, like the color and basic types like strings and so on. But I was gonna just show you, just gonna start. So okay, so now you can start running it. So you just hit execute, and I believe it worked. Yeah. Okay, at least it worked. Let me see if I can move it so you guys can see a little better here. Okay. So there is a visualization that you can kind of play with. It doesn't really do much. But this is kind of how you run it. Okay. Now, each of these you can think of as a functions. It's like the data flows from the top, and you just kind of split it, and you have different functions that take different inputs. So you should be able to think in fairly easy programming terms. Now, what we can do is do a little bit changes here so that all right, so because some of these modules here are really extensive, like the VTK, which is the graphic one, so this is all the graphic primitives that you have in there, which I think unless you're really graphics guru, I have no idea what most of those things are, but it provides some really nice graphics. So. But we're working with the Vistreals team also to, I think they started to do things a little bit, group things a little bit better, so we can do some better visualization without having to be a computer graphics expert. But because there are so many of them, you can actually search. Okay, so I can search, and then you can just move the new module or new function there. So instead of a quadratic function, which we can just delete, we bring in a cylinder function, and then this is the output from the cylinder function. These are all the possible inputs to the VTK sample function. And what it does, what actually Vistreals will do, it will automatically snap to the port that the input matches, because otherwise, it gets really tricky, because some of these have real large, especially in the graphics, they have really large amounts of. And it will tell you if you kind of hover over the port, input port, and what is the type, VTK implicit function. Now this one says VTK cylinder, so well, when you can look, okay, you gotta select it, and you look at the documentation. And I said, oh, the superclass of it is the VTK implicit function. So, since it's not really important now, but think about it, it's a type of the implicit function, so it matches the input port. So we can run it again. And, let me get rid of this. Okay, and now we have a cylinder instead of the quadratic function that we had before. Now, each of the functions, just so you imagine, can have a number of parameters. So what we can do on the right-hand side, we can modify the parameters. So we can change the radius. So we change it to 0.25, and then run it again. You generate another cylinder with a lot smaller, radius in the middle. The nice thing is that this might be something that Chris Hanzi also showed you now. So you can actually manipulate these things, at once. So you can actually see and compare results. This is good for a 3D object, for like zooming in and zooming out. But it's helpful if things get bigger. Plus you can use, this is called the Vistreal spreadsheet, and you can actually use it to populate it, however you see it fit. So you can have all your different results kind of across it, and you can manipulate all of this at the same time, so you can really explore the results, for example. All right, so let me close this. How are we doing on time, Jennifer?
We're doing great. We have half an hour still.
Oh, still half an hour. All right. Well, I have a lot to say still. Okay, so the next thing I was going to show you is Python source. So because this is all done in Python, and sometimes you don't have quite the module ready and you don't want to integrate it all externally, you can actually add a Python module in here as a source. So it's great for debugging, it's great for integration of modules. So if I just search for Python here, I get a Python source module out here. Notice it doesn't have any inputs. And it doesn't have any inputs because it's basically a blank function. So I can edit it, like edit configuration. And what it brings out, it brings the editor. And I can say, okay, I'll take an input. I'll create an input port, call it radius, and make it of type float, and then just print it. Okay, I'll save it. And you see that now I have an input port here that if I hover over it, will tell you it's expecting type float. So in the cylinder here, actually what I need to do, I need to enable the radius output. So these square ports here, those are the default inputs and the default outputs. There can be a lot more that you can enable on this right-hand side. So I can actually enable the radius port, by clicking on that, and it makes a little circle here instead of square. And it kind of means, this is a optional port. So it's not something that comes as a default. And then, oh, imagine that it's type float. So I can just connect it to the Python source, and I can run it, and bad things happen because my code was wrong. So you see, so red means bad things happen. So it means the module failed. But I can just kind of put my cursor on it, and it tells me what the error was. So I know this was a controlled experiment. I know that I forgot one of these in here in the code. So I can save it again. And then in order for us to see the results, I'll add this console view. It's basically, you basically get a shell console here. And if I run it again, everything is green, and on the console it prints, So just think how useful this is for debugging, all right? So this is one way you can just bury your print statements in there without having to do really anything. All you need to do is, it's useful for a lot of other things, but that's one of the first thing that kind of comes to mind. All right, now you can do other things with the, so it's just this Python source, so it's not really a descriptive name. So you can change it. You can say best function, and just kind of changes it as the main, so you can organize your code a little bit better. Now, okay, let's get rid of this. 20 minutes. So the other thing you can do is group modules into sub-workflows and groups. So you can select a group, and you can say, all right, group it, and it just basically create one group. You can name it just like you would name a module, and it just provides a way to do a little more readable code. There is another functionality which is so let me back out of this. Instead of a group, you can create a sub-workflow. That sub-workflow you have to name. And the reason you have to name it is because it actually creates, it puts sub-workflow in your basic modules. So if I go to my sub-workflows, there's my, now what it means that if I group it this way, I can now share it with other people. It's like a shareable component. So if you think, like you can reuse some parts of your code. So there is some differences between the groups and the sub-workflows. Some of them has to do with the history changes and so on. You can probably read it up pretty easily in the tutorial. Okay, so now we're gonna do back out of this. Now it's the version tree. All right. So that's gonna be another view, and this is, let me move it so it's not running straight through the middle there. What the version tree represents, it's the trail that was showing you before in terms of the editing of the photos. This is, this is linear in this case, but this is basically what it represents. It shows number of things. So the shades, different shades means it's like different time. So the more color you have in there, it's more recent, and so on. And you just kind of can follow it down. Now the color also, there's two different colors, and you'll see it a little bit later. There's the kind of orange that was created by somebody else. Usually, I can click on it, and then so you can see the name here. And then it should be blue. So blue would be created by the user who is using it now. So you'll see an example of that in a little bit. So for example, we can select this. And the nice thing is, okay, so you can go between all these different versions of the workflow. So if I select the quadratic, this is the only thing that's there. Because that was how we started the workflow, and we decided to tag it. Okay? But I can select, a little bit further down the road, I select the almost there, and I go back to the pipeline, and it's a lot bigger pipeline. And if I go here and, delete this particular module, then I go back to history, and it shows, that I just did. I deleted the module, and I can, decide to tag it, and it keeps the tag new version. It actually keeps track of a lot of different things. So it keeps track of moving things too. So if you look, edit parameters, change parameter, but it will only, but because those trees would get really big, so it only shows the components that are tagged and the leaf nodes. So if it's a leaf node, like this one here, like the new version, it will show it. Or if it's tagged. So tag means, you kind of annotate it, or here you put some kind of, like this sample function stuff here. And that usually means this is some kind of checkpoint. It's something important. It was a one point in your exploration, and so you can kind of go from there. All right, now getting to a few other things here. Next thing you can do, which is, also I find it extremely cool, you can compare versions. Okay, so this is a little bit bigger. It's not really, it's not really that important to see what the. Now this tree is a lot bigger. There's a lot many versions. You can think that there is somebody who was really exploring. But what you can do is say, okay, so we kind of said each of these represent us, like an experiment, and then from there, you just go like editing the photo. But you say, well, I want to know how this experiment here that I followed down here is different from this one. So what you can do, you can actually take it and you drag it. You can drag it, and it will show you how those two workflows, or the two thought processes that went into creating the two separate components are different. And what you can do, you can look, I'll zoom in a little bit, and color coded fairly well, so you can see these particular ones were from one version, the orange one, the blue one from the other version, these kind of lighter gray were, I think they're shared, because they had, yeah, okay, so these had parameter changes. And what it means, you can click on it and it'll actually show you how was the parameter difference between the two different versions. Okay, so that's I think it's another really cool version. I mean, cool feature. Next thing is search. So we go to, let's see, should I open our screen? Okay, so there is a, so there is your workflow, and then we can try to search. And they have two different types of search. You can actually search by example, and what it means that you can find workflows where several modules are used in the same way, in a sequence. So what I can do, because if you just want to do it in textual query, it may be a little bit harder, but you can actually kind of draw it and it will find it. So one of the things that you can do, let me give you one example here. Shader files, allocation, rich text cell, connect these. So basically you build like a little workflow, and then you hit execute, and you say, oh, okay, so only this particular version had that sequence of modules or sequence of calls to functions, whatever it had in it. You can click on it. This doesn't work now because actually theoretically it should highlight also in the main workflow the components that were fine. But I think it's a bug in the new version. Next, you can do you can actually search by parameter. Okay, so this is one of the other versions, and I can go and search, and this time I'll just search for, I think that's the one. Okay, you search for it, say, oh, okay, so you have plenty of versions that actually have this particular module in it. But what you can do, you can say, I'm only interested in the module where the parameters were set in a certain way. So I can go back, and I can select it, and I can look, and I can say, okay, I only care where this parameter here was greater than like 90 degrees. And you can do the search again, and it comes out with only the particular runs that were done with parameters that had that had set in a certain way. So I think it's, once again, if you have a lot of explorations, you can actually really dig into your results, and you can find exactly what you did in certain time. You can do text queries too. So you can search for. So let's get rid of this. You can search for things like user. So she did the whole thing, so it comes with Visual, so that comes there. But you can also search by other things, like you can say search for dates. You can search, let's say, after 24 2010. So it selects some. If you change the date by 1, so you'll see that it actually does work. It picks only the specific ones. And there you can do relative dates, like after 30 minutes or 30 minutes from now, or so on, or like 30 minutes ago. You can also refine these. So if I go back to this, so this kind of gives you the broader picture, how it fits in the overall picture. But if you want to see how these particular versions relate to each other, and how you can actually refine it, and what it does is it's going to compress the graph into just showing you how these particular versions relate to each other. Okay. 15 minutes? Okay, good. Because here's one of the things that I was going to show, which I think is what actually got me really interested in this. Okay, so, and that has to do with parameter exploration. I mean, and these are nice examples, and so you should think about some of these features that you're seeing and how you think it would fit with what you do in your experiments and so on. So let me clear this out here. And so we go to the history and we start here. So the pipeline for this, it's not extremely complicated, but there is a really nice feature here. So if I execute it, it will run. It provides this. It kind of gives you this picture. Medical community, I think, is using a lot of this. So that's kind of now. If you want to actually explore a little more on what's going on, you can look at the Explore view and you can say, okay, I'm interested in this particular function, and these functions are based on, in your entire workflow, what are the parameters that are being set. So it can be, one of them can be like plane cover. You can say, well, it can be like IGBP or BU or whatever. So in this case, it's this, and I can say, well, I want to look at these values between 30, like 30 and 75, and I want to display it along the x-axis. And what it's going to do, I was going to do 2 runs, and it's going to show me 2 different things that I can kind of explore at the same time. So that's nice, that it does. It does those 2 things, but I can actually say, I actually want more. I want to go, let's do 4. And what it's going to do, it's going to do linear interpolation between the 2 numbers and actually pick the other numbers in between. So you can run it, and this time it's going to create 4 images. At different with different changes in terms of the parameters. So that's great, but linear interpolation is not always what you want. So what Vista also provides, you can do actual list. So let's say instead of, let's make this 3, you can just pick whatever you want. So you say start 30, and then we do 40, and then we do 70. Okay, and I run it again. Now it's going to generate, all the images based on that particular list. Once again. Now, the last thing that you can do is actually create. If that's still not enough, you can actually create a function. So you can actually have a user-defined function, Python function that will say. You can just create an array. I'll make sure this is a little finicky. And you just return the list. So you define a list and you return the list. And it didn't work. Oh, I know why. So the trick is that this is a float here. And I was running into it earlier, and these are not. So you can either cast it at the very end, or you can actually make these floats, and hopefully, fingers crossed, and then you can once again. So, and this function can be arbitrary complex. So if you want to use, some kind of function to call web service and provide you some numbers, you can still do that. Now, the last thing for the exploration I'll show you is you can actually do this along more dimensions. So let me see. So you can actually pick a module here. Like this resample module. Delete this. Connect them. And then here you pick. You can, in order to for this to show up in the exploration, you need to set one of the parameters. So is it set? So 0 and 0.2. Okay. Now, hopefully, yes. If I go back to the exploration, now it showed up here. So now I can actually do, okay, so I have 3 parameters. Once again, I can just go for the simplest, I'll do the linear interpolation between these 2 numbers here. But I can also set this one, and I can say, I want to go between, 0.2 and 1, and I want to show this along the other dimension, and I want to also make it, 3 wide. So basically what you're going to do is you're going to do 3 by 3 grid of all the combinations. So if you run it, it's going to take a little bit longer now. 9 minutes. Mm-hmm. Okay. It's still going to run 9 minutes.
Are you going to have a little time for questions?
Yeah. Oh, this is actually the last thing I wanted to show. And then I have a few more slides, and then I can take some questions. Awesome. Okay, so now, so now I basically generated all different, and along different dimensions, it's, how you vary the parameters. So it's, once again, you can explore, your work in multiple dimensions, not just one. If you throw a little more in there, it gets kind of tricky, but, it's something that, I think it's very, very useful. I'm not going to show that, but you can actually create, well, maybe I can. Can I? You can actually create these mashups. So if this is like too complicated, or like you have think about it like an applet that you want to run, over and over. You can actually create like a simple application, and actually called mashup. And so instead of like modifying the parameters and so on, you can actually say turn auto update, and you can change the opacity, like things like this, which is nice because it still tracks the provenance behind the scenes, but you don't have to actually modify. So this is nice to actually give, some other people to explore, like your boss or something, if they want to, look at the results and try to look at it from all different ways. So that's that for Wistrails, and I have a few more slides that I was gonna show you. It's kind of work. Oh, this is still running. Okay. Just changing some permissions. Actually, for you guys, I think. So, and how we're actually looking at the goal of NEX and how does this fit in? I mean, we have this collaborative process design and knowledge capture. So what we're looking at is, having people do the process design, then do this iterative refinement, through the exploration that something like Wistrail support, and then move it towards full-scale execution, and then move the results and do online result sharing and the process reuse of these modules that were developed. Some of the additional integration, we're integrating Wistrails with some of the NEX semantic components that we're developing. So we're trying to bring together provenance and semantics. And we're also developing workflow engine to interface with the Playday supercomputer, so that you can actually go from running Wistrails in exploration mode to actually running them on very large-scale problems. It provides some challenges, not necessarily with the execution, but with the provenance. It gets a little tricky on how you actually keep track of that. Some of the examples where Wistrail is used, there is a ultra-scale visualization climate data analysis tool at the Lawrence Livermore National Labs, which you can also download, and it provides some phenomenal visualization capabilities for climate data. Vistral also have their collaboration site called Crowd Labs that we're looking at integrating with the NEX portal, from which you can actually move some of the work that you did and publish it directly. They have also this concept of executable papers, where you actually use LaTeX to bury certain markups within PDFs, and you can actually open the PDF and you can experiment with the figures there. It's pretty wild. So people can actually look what you really did, and it kind of goes back to the portal. And the team has been one of the finalists for. There's been this executable paper competition. So this is something that's still under development, but I think they're really moving forward with it. There's also some of the future work they do on climate pipes, which is web-based interface to Vistral, so you actually will be able to do this online. Some of the publishing, they have scripting support. So if you don't want to actually really mess around with the user interface, you can actually just write Python code that will call all those different modules. So this is basically it. So it's very straightforward. And in the background, you still get all the provenance and all the keep track of records. So so they really, I think it's really good. Now, final thoughts on reproducibility. So workflow is just one of the components. It's a good start, but it's not enough. We need to capture other system information like the OS and the database and the libraries that were used, in creating the products and the executables, and the configurations, version configuration options and so on. Virtual machines may play an important role also, and there is a great reproducibility info that was actually done by one of the people that were working on Vistral this year. Actually, I think it was really recently. This reproducibility tutorial link is there. It's really, really good. It's not overly technical, and it captures really nicely a lot of the thoughts on scientific reproducibility. And that's it. So thank you. Questions?
Questions in the room? There are a couple questions. Oh, go ahead, Jared.
So how to integrate this with your own work? Say I have a Python program that takes in input data, gives output data, sends it to another Python program down the chain. Can you use that for that type of thing?
Yeah, absolutely. Yeah. I mean, there's basically what it is to do the integration. It's just you write a very, very thin Python wrapper. You describe in the wrapper what are the inputs, what are the outputs. Okay. And what is the code in between? And the code in between, basically to implement like one function, and it is how it's being called. So you can call, executable, you can call, web service if you want. Even though they have separate components, they actually support much nicer, integration web services. Or you can just call another Python library, that you have. So I mean, we have some of the examples that I worked on with NEX. So we have like the NEX platform that has, some data management. Like databases and things like that, and you basically just include it and you call it from there, and that's it. And whatever that calls, sometimes it's a little tricky with dependencies, but yeah. So that's fairly straightforward. Yeah, and the tutorial actually is pretty good too, and showing you how to integrate the simple, the very simple cases. Yeah.
And that was actually the same question that was in the chat room, along with another question about has the next group changed the Vistrail's code, or is it the same?
It's the same. It is the same, yes. We will, we're working on changing the processing engine, but we're not really changing not yet. We haven't started yet. Yeah. And, we're working with the Vistral team. They're part of our, some of our other projects. So, we've been fairly well connected with that community.
Okay. Thanks a lot, Peter.
That's it. All right.